Alright, so with the second diagram under the first one, let's see. This is the second one. We also have is the same idea, the same theorem, but the diagrams is what we have to note. Now, with this one, you are saying that still the chord. You are dealing with chord. The chord forms, let's say this is our center. The chord forms an angle at the center here, right? And the same chord again here can also form an angle at any part of the circumference. Remember that it's not always that it should be one way. The angle formed at the circumference will always be here. No, it's not possible. It can be at any side of the circumference. So if this side is A, and this side is what the chord and forms an angle at the center as well, A. Then meaning this same chord again forms an angle at the circumference here. So meaning this side will what? Will be B. Now, if A is here, this diagram is the same as the first one. So with this one, it tells us that half of what the mother, this implies that if I want to get what the top side, which is here, then B will be equal to what? Half of what? A degrees. And if B will be equal to half of A, then what will be A? A degrees will be equal to 2 times what? The B. So that's the idea of what? The difference in between this and the other one. It's the same thing. But just that I want to show you another way of drawing the first diagram I drew. Alright. Now let's see the third one diagram under the first theorem again. Then we move to the second theorem. Also, another way of drawing this would be if you have a chord. A chord forms an angle at what? The center. There is it, the center. And this same chord again forms an angle at the circumference, but it will pass through the center. Please note, this is also the same as this, and the other one as well. So with this one, we are saying that if this side is O, your center, and this is the angle formed at the center, A degrees, then this same chord again forms an angle at the circumference here. But just that we've cleared this part and we've placed it on this one and extended what? The line. So meaning this side will be. Now if this side is A, then it tells that this implies that A degrees will be equal to 2 times what? B. That's the meaning. Then if I want to find B, then B degrees will be equal to half of what? A degrees. And that's the idea. So this is the first theorem. Now let's look at the second theorem. Then we move to what? The third theorem. The second theorem states that a chord forms an angle. A chord forms an angle at the circumference at any side of what? The circumference. They said the angle that it forms are what? Equal. So with this, you are saying that if I have what? A chord can be formed from the to the circumference here, right? 1. That's the first one. Let's say this side is our, let's say this is the first one. And the same chord again can form an angle here, right? Then the same chord again to the other side. Since it's touching the circumference, since it's what? It's touching the circumference of what? The circle. We are saying that then the angle formed at the circumference are equal. So if this side is what? Is A degrees, then the other side will be what? B degrees, then this side will be what? C degrees. So we are saying that then therefore this implies that A degrees equal to what? B degrees equal to what? C degrees. And that's so simple under the second theorem. Now let's move to the third theorem. The third theorem states that a chord, the third theorem states that a diameter, right? A diameter forms an angle at what? The circumference. A diameter. What comes in mind? It's not a chord. We are not looking at chord now. We are looking at a diameter. Now, what is a diameter? A diameter divides the circle into 2 equal parts, not 2 unequal parts. It's only a chord that divides the circle into 2 unequal parts. So with this idea, what comes in mind? It tells that when a chord or when a diameter divides the circle into 2, you have 2 semicircles. But when a chord divides the circle into two unequal parts. It tells that one of what the side becomes what a major segment, and the one below becomes what the minor segment. So a circle itself is a combination of what a minor segment and what a major segment combined to form what a circle. Or a circle can be used, or a circle can be formed from what two what semicircles. Using two semicircles, it forms an angle. It forms what a circle. Sorry. So with this idea, we are saying that a diameter. It tells you that when the chord passes through what, or passes beside what the center, it's still a chord. It's not a diameter. A diameter always passes through that center with the dot. So let's see. If this is my center, we are saying that a diameter, when a line passes through or is below this one, since it's still below, I told you, a chord is always below the center. Either it will be below or above the center. It tells that it's still what a chord. So meaning if this is a chord, even if it's here, it's still not passing through the center. So it is still assumed that, or presumed that it's still what a chord and not a diameter. Not until it passes through what the center. So let's say this is our so this is what our diameter. Now this diameter forms an angle at the circumference. Here you are saying that the angle formed at the circumference is what 90 degrees. If the angle formed at the circumference is 90 degrees, then meaning what you are trying to say is that then an angle, let's say this side is our A, B, and what C. Then we are saying that angle A, C, and what B will be equal to 90 degrees. That's what the theorem is saying. Why? Because it's passing through the center. So in other words, when what you interchange the diagram, I can redraw this one and get a right angle triangle. And that is why we are saying that is what a 90 degrees. So meaning the 90, you can turn this AC and what CB upside down, and this side becomes what your C, and this side becomes what your A, and this side becomes what your B. In other words, the diameter here or the AB becomes what a hypotenuse. So meaning here becomes the hypotenuse. That is the reason why we are saying that this side is what 90 degrees. So remember, this side can also be drawn. Another way of drawing this one, it can also, it's not always one way. This is still a diameter, so it can also be down, right? It still forms a 90 degrees. Alright, so that's the theorem 3. Another diagram under theorem 3 is that the second one, you have the same circle, you have what? A center. You have A, you have B. I can just, from here, not always here, no. There's no rule, or there's no laid down rules that always when a chord or a diameter forms an angle at one particular circumference, then always it should be that same side. No, it shouldn't. So what you are saying is that it can also be at this side. It's still 90 degrees. The same thing again here can also form 90 degrees. The same diameter again here can also be 90 degrees, right? Then as well, down here can also form a 90 degrees, right? And also again from here, it can also form a 90 degrees. So 90 degrees can be drawn at any side. So you have to be very careful. I'm drawing all these diagrams because there are some questions that is not normal, like you don't see it clear. But they've applied that rule. They are not using the first one. So you will be thinking that, oh, the first part is what they are using. But not knowing there's another way of drawing the same diagram, or rebranding the new, or bringing out or generating a new diagram. So you look at this one, they are the same. But where the angles are not the same. Look at this side and look at where this angle is. It tells you that there are so many ways of drawing the diagram. Alright, so that's the idea. So also angle what? ACD will be equal to 90 degrees. That's the idea. Now let's look at theorem 4. Theorem 4 says that a chord forms an angle at opposite side of what the segment. Now, when you say opposite side of the